Okay, so we are going to start with chapter 4. Even though we already started the graphing calculator, this is the actual chapter, okay? So the first part is just kind of an introduction, and it's a lot of logic, okay? So we're going to start with this, analyzing a graph. So this is the graph we're looking at right here. Air in a balloon, right? And then we've got time, so how much time it took, and the volume of air in the balloon. Okay, so it says the graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? Describe how the variables are related at various points on the graph. Okay, so in science, hopefully you talk about this as well. So the variables are always labeled on the axis, okay? So your independent variable is always this way. This is called your independent variable. And this is always your x variable, your independent. And your dependent variable is your y variable. And it always is that way. It means that the volume of air that's in the balloon it depends on the time you take to blow it up, right? So if you look at this, right, it starts at no air in the balloon. You blow the air in the balloon. What is happening right here where there's like a plateau? You're taking a breath, right? You can't just continually, unless you're not blowing it up like as a human, you're using an air pump, right? Or one of those electronic ones. That's what's happening. So what are the variables? The variables are time and what? And volume. Okay. Describe how the variables are related at various points on the graph. Okay, so what we want to do to describe it, we want to say we always talk about the independent variable. So we're going to start with that. And we say like this. Our description is as the time, all right? That's what we always start with. As the whatever that independent variable is doing what? So as the time, right? If this is 0, is the time increasing or decreasing? Yeah, as the time increases. And then we describe what the dependent variable is doing. What is the volume doing? The volume increases. And then you kind of, if you can, give some descriptions, right? At intervals, right? It stops. Until when? What happens way over here?
The balloon pops.
The balloon pops. So is the volume increasing then? Until a massive decrease at the end. All right. And so I'm just, I'm getting into a lot of detail here, but when you are asked to describe how the variables are related, the main point is this. We are looking for our independent variable, what it is doing first. As this does this, the dependent variable does this. That's what it's asking you to do. All right. As we get going through this lesson, we are going to put numbers on this, right? Like if it's constant, we're going to give the number it's increasing by or decreasing by. Okay, so that's the first thing. Second thing is another kind of logical situation, all right? It says match the table and the graph. So here's our table, video downloads, day 1, 2, 3, and 4, and the total downloads. So what is happening here, do you think? Right? Look at this table. What's happening without even like any... Yeah, somebody posted a video, right, that needs to be downloaded. And what is happening is that more and more people are downloading it each day, right? Okay, so A band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? So, obviously, right, we can see that it's increasing, but this graph is increasing by the same amount each time. This graph shows what? It's increasing, and then what's happening? It's like tapering off, right? This graph starts off low and then increases more and more. And this graph, what's happening here? Okay, so which one is automatically out? D is not, right? We know, we can see it's increasing. But what we have to decide is it increasing constantly? Is it like tapering off, or is it increasing more and more? All right, let's figure it out. How do we figure out the increase from here, day 1 to day 2? What would we do? What would we do, Anna? Yeah, so what do we got to do is we're going to do the second day. We got 1,011. 1,011 minus 346. What do we get? Use your calculator. Give me an answer. Louder. 665. So this added 665 downloads the first day. All right, let's find the next one. So the next one, we subtract the next set. 3,455 minus 1,011. What's the increase between day 2 and day 3? 2,444. Okay. And then the last increase is 10,426 minus that 3,455. What's that increase? 6,971. Okay. So is it a constant increase? No. So we know it's not D, and we also know now that it's not A. So is it increasing and then tapering off? Or is it increasing more and more? So our answer is B. Okay, again, kind of logical stuff here, right, to start off. Okay, now, this is the next part and the last part we have to learn for this first one. And this is on your exam. Okay, so this is not too bad. The part that's hard sometimes is figuring out the variables, all right? So we're going to sketch our own graph. All right, a model rocket rises quickly and then slows to a stop as its fuel burns out. Okay, it begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight? Label each section. Okay. So we actually have to start with our labels. So here's our graph, right? We need 2 axes. And we know we need to label our section. So what are going to be our variables here? If we're talking about a rocket launching and then falling back to Earth. Now, one of the variables is easier to think about than the other. Give me one of them. Height, okay? And the height is actually the dependent variable, right? The independent variable is harder to think about. So if the height, right, is going to go up and down, so we know it's going to go up and then fall back down, but what does that depend on here? Nope. The time. Okay, so the height, how much fuel is in there is not determining how high the rocket is. Does it say the rocket runs out of fuel? No, it doesn't. So it's the time. So the time is 0, right? And the height is 0. It's starting, is it going to start at 0? Right? At time 0, where is it? On the ground. And then it rises quickly. So what is this first part going to look like? Increasing, kind of like slowly or steep? Steep. So we're going to start with a steep line. Then it slows. So then, like, does it just stop at a point?
No.
It's going to curve, isn't it? It's slowing down to a stop as the fuel does burn out, right? But then it begins to fall quickly. Steep again, right? All right, it's falling. Woo! And then what happens? The parachute opens. And then what happens? It starts, it's like, whoop, and now it's like, nice fall to the ground. And does it hit the ground? Yeah, it's going to hit the ground. Okay. This is the sketch of the graph. Okay, this lesson starts out very ambiguous. Eventually, we're going to put numbers with all this stuff, but it is using your logic to figure this out. Okay, so let's go. Hopefully, you have grabbed 4-1 practice. Okay, and we're going to practice with this. So if you're at home, 4-1 practice is what goes with this. There are only 11 questions, but we're going to stop the video.